Okay, so I'm going to be talking about exaCB, which is a continuous benchmarking framework, and what things we want out of exaCB and how it affects our needs for EasyBuild. I must say I'm more of a user of EasyBuild rather than a developer, so the perspective might not be the one that you would get from EasyBuild developer, but maybe from the user point of view. All right, so uh, as you know, we are getting Jupyter, and we want to test it out as it builds up, and then there are so many factors that go into it. We have a new kind of an architecture. There is a smart unified memory, and we have power sharing between CPU and GPUs. All of this kind of significantly affect how people will be programming their applications and changing this. Apart from this, what we have is the mean time between failures now becomes hours to days instead of maybe much longer before, because of the sheer size of the system. And that's how the continuous benchmarking becomes very important. So what we want to do here is we want to track the progress over time and also track the progress to the changes in the software system. Like when you are bringing up the system and you want to change the stage, or you want to have a new driver, or you want to fix a bug, all of this. So we have been running this early access program, and generally what we found is that when we get these early access applications, they come with their own custom versions of dependencies in the starting, and they have their own custom compiler flags because they are used to a different system and not our system. And so when we onboard them, the first job is the most difficult, where we want to get them to run on our system, and this first time to run is a very significant factor. And this is, I feel, very important as well. Even if you cannot run a very big application in the starting with the best performance, you should be able to run something. So this is one thing. The second thing is, because I think we have around 70 applications now, or even more, in the early access program. When we as sysadmins or the center people look at these applications, we want to be able to replicate what they are doing. We want to be able to test all the things that they are doing, and especially when we have new updates to our slum or new updates to our software stack and all of this. So for this, we really need a well-formed auditable execution of benchmarks, which can be continuous, and we want to really do rapid testing of the deployment of a software stack. And the software stacks can be complex, right? So for example, this is I don't remember which application this is, but this is the dependency graph, and now this is a two-edged sword. You might think that really complex dependency graphs are not very difficult to manage, but then you also have to think, now that the systems are becoming much more complex, if a application is not using this complex dependency graph, maybe it is implementing a lot of things in house, and maybe that's not also optimal. So it's not a one-to-one, but good large dependency graphs are not necessarily bad. They might be actually good. Then there is this slide as told from back things, but this is how much combinations they have of their dependencies. And of course, they are not everyone is going to use all of them, so there are not 1 million combinations in existence. But it also means that whatever combinations you support as sysadmins, or we support as sysadmins, is not going to be enough, because there will be one application, especially in the starting when things start out, where you have multiple combinations which you might not support. And so why so this is one of the reasons, so early access program. But then there are other things that we want to do, where we want to run continuous benchmarks on a large number of applications as sysadmins and as users as well. So for example, if you want to do energy measurement and we want to do optimize our system for performance, then different applications will have different behaviors. So on the left you have one application where the best thing to run is somewhere here on the bottom left, because it's a memory bound application, but here these are the sweet spots to run. And if we look at all our users and figure out where they are running, and if we can do this experiment ourselves, then we can figure out what to do, for example. Then there's another thing which is about scheduling, is again related to energy efficiency, but also other stuff. So here you have this complex data dependency graph. So each of these nodes is a separate Slurm job, let's say. And then this is a graph from an old experiment where what we did is, instead of transferring the data from the files to the file system, we transferred it through the memory using some specific server jobs and some framework called Maestro. And what we found was that we could improve the performance if we schedule the jobs on the similar nodes. So all these graphs are kind of all these nodes in the same similar graphs are scheduled on the similar nodes, these kind of things. So again, now to find out whether this is useful or not, whether it actually works or not, we want to be able to run these benchmarks not just for this kind of a test system, but also real life benchmarks. And here also, that's why we need all these different continuous benchmarking. So we came up with this. So whenever we try to do this large scale continuous benchmarking, one of the big problems is how to get all the people to do stuff in a uniform manner, so that we as sysadmins can also run this. And what we came up with is this framework. It is still in very early phases, and so we started with a template based CI/CD syntax. So for GitLab, we used the GitLab CI/CD components. So we had a declarative syntax which people can use, and I'll show it later. And the aim was to reduce the barrier to entry for the continuous benchmarking, so that people can do continuous benchmarking. They still have to implement their code, they still have to implement a reproducible workflow, but then the CI part and the data part, or the data storage part, and all of this can be taken care of. This also means that now, once all of this has been implemented, you can click on the GitLab CI and run the benchmarks. And if you want, you can run all the benchmarks and all of this. And most importantly, like when people have their benchmarks in the GitLab CI and they're running it through that, and on our systems, we use the GitLab CI through Jacamar, which can run the CI on the supercomputers. We can share the workflow. So if our application has a bug or a problem, they can just give the link to the job to the sysadmin or to the support person, and we can figure it out. Or there is a process, but this is much more easy. And what we were able to do is we were able to get around 70 applications to use this. They also had to do quite a bit of work, but then what they got in return was this automated report generation, automated energy measurements, which I'll come to in a moment, and what we got was system performance evaluation and stuff like this. Yeah, so how does this continuous benchmarking look? So the way this continuous benchmarking looks is we have a CI/CD component, GitLab CI/CD component, which the people can include, like shown here. So they include this component and they pass it some inputs, and then this component sets up the computer count and reservations. It runs some fixtures or setup and tear down, which the user can provide, and then it runs the benchmark, and then it generates the reports and uploads the results either into the repositories or in future in the S3 data storage that we might have, MinIO based data storage. And running the benchmark, now this is the reproducible part, which is the most important. And what we asked our users was that they have to make it such that it can run with this command. So JUBE is a benchmarking environment framework at JSC, but we did not we encourage JUBE, but this can be done with this can also be done with Reframe, for example. And with this command, with this inputs and then the JUBE file, you run your benchmark, you get the scaling plot. This is some data, and then you do all of this. And then once they do this, they can get they can generate the report based on which pipeline was the last CI job executed in, and then they can select which data reports they want and stuff like this. And so we implemented these components for them, and then they had to implement this JUBE based reproducible framework, and then things worked out quite well. What we got also for free in this sense was, now we could do energy measurements as well. So we had all this reproducible benchmarks, somewhat reproducible, let's say, and then we could change our components such that instead of running the srun in the JUBE, when it runs the command, it runs srun with the jpower, which is our tool for measuring power. And so we get the power profile of the applications. We ask the applications to give a start and the end time for the computationally important part, and then we can get the power, we can get the energy, and then we can, and that's how we generated all these plots. So all of this is quite good for now. It still needs a lot of work, but we have these continuous benchmarks, and now we want to extend this to our software stack a little bit as well, our synthetic benchmarks, so that we have a good handle on what the system is continuously doing. So when we started designing this framework, or we started implementing this, there were two main kind of factors that we had. The one was a technical factor, where we wanted the scheduled runs, we wanted report generation, so that all the reports look the same, so that we can compare them quickly. And then we had the data storage. So once you run the benchmark, you want to store the data. Currently we directly store it in the GitLab repo, but maybe also in S3. And we also want to think about automatic alerts, where, for example, if a benchmark fails in a non-trivial manner, we want to send either through a GitLab failed job or even an email. And then there were these community factors, we wanted to enforce reproducibility. And what does this mean? So when we are running the job on the CI is assigning, the CI is using Jacamar, and Jacamar is running the job on the login node currently of the SIP of the machine, and the login node then allows us to submit the job either through Slurm or again through Jacamar CI to the compute nodes. And there are a lot of factors which come now here in play. Which file system you are running from, what data access do you have, because you still have access to the parallel file system. So all in all, the access to the parallel system, maybe the user has the access, but the support person does not have the access, and now this becomes a problem, for example. So or the user has access to a specific binary that they are downloading, which the support system again does not have an access. So we really want to enforce reproducibility here. What the community gets out of it, what the users get out of it, is now they can compare the benchmarks to a lot of different benchmarks, and then they can realize whether the benchmark is the bug is in the benchmark or the bug is in the system, and flags can be raised. Also, because we have this component, GitLab CI/CD components, which can be included anywhere, you can also do this with you can integrate your benchmarks in your development repository directly, so that people have first class access to the reports from the benchmarks on the systems, such that, and then they can accept or deny a PR directly based on this. Whether it always makes sense or not is different, but maybe this is a good access to have. And so as I talked about till now, I have emphasis on reproducibility, but what does it mean? In different cases it means a lot of different things, and what I mean here in this specific case is I have 3 columns: required, optional, and uncontrollable. So required is what we definitely need, optional is what would be nice to have or maybe needed in specific cases only, and uncontrollable is what we should not control for, cannot control. And it's very standard. So required is version dependencies, including the flags, which the versions with dependencies were built with. Also the build system itself, but I'll come to that in a moment. Slurm configuration, including the defaults, and the environment configuration. So this reproducibility is kind of required. We need to have good control on this. If we can have bitwise reproducibility, then it's very good, but I think that's the ideal. But even if we don't achieve it, we can work without it, I would say. And then sometimes when the hardware goes bad, then you want to be able to test on the exact same hardware again, to make sure that that is the hardware which is the problem, and not the general, it's not a transient bug or something. And environment isolation is ideal again, but I think sometimes it's almost impossible to achieve, and sometimes even counterproductive. So I put it optional. And then there are uncontrollables like network effects, IO effects, parallelizations, driver and OS updates. And what all of this means is that even if the benchmark is running, the first things are reproducible, the last thing is not, and your results might not be bitwise reproducible in your simulation, but for me it's still reproducible from my point of view, from the setup point of view. Yeah. So once we have this, then we think about so what does the application need to do to run this benchmark, and what steps are there, and what of these are reproducible and how. So configuring the environment, which means configuring the authentication tokens and all of this, and this, it's just a pass or fail. We don't consider this in reproducibility. It changes with time, especially time-based tokens, temporary tokens. Then the applications will need to load data, and once they load the data, then so this data they should be able to audit this, and they should generally they would checksum this and fine. Then they should load the dependencies, and again this should be reproducible, and whether now they can actually check for reproducibility or not depends on the dependency manager here, and I'll come to this in a moment. And then build applications. So when you build applications, also now technically you should be able to reproduce this with environment isolation, and generally people call this build systems as hermetic build systems, but this is almost impossible to achieve or difficult to achieve. There is Bazel, but very few people use it. And so what generally people do is they go to the dependencies and ensure that the dependency environment is reproducible, and then the build system only sees the dependency environment. So this the fourth thing people generally exclude. And then running the benchmarks and uploading, the reproducibility here, for now we provide it with exaCB. And as I said, this is very useful for auditability. It helps in debugging on the support side. Shared techniques mean faster onboarding. People can onboard their applications faster, and we can check quickly what is being broken, what is not being broken, and we can prioritize our efforts that way. And since it's an EasyBuild talk, I am going to look mostly at auditability and reproducibility of the dependencies. So I did a survey for the 70 applications that we have, and I tried to figure out what applications and what dependencies they used. 68 applications here, and 20 of them used only EasyBuild, and the maximum number of dependencies I could find they were using explicitly. Whether they were chain loading more dependencies implicitly, I did not check. For now was 12, and out of these 20, 16 were rerunnable, which means that I was able to run them with my permissions at least. It's not a very good study, but I think this is enough. But then there were 48 applications which were generally out of they were using the EasyBuild components for compilers, but then an MPI, but then a lot of applications were used, dependencies were used from outside. So some of them were using out of bands completely, so they were using containers or they were using SPAC. There was some of them were using pre-built binaries, some of them were using in situ or ad hoc compilation, which means they were using scripts, bash scripts to compile the dependencies, or using fetch content, CMake and stuff like this. Some of them were compiling their dependencies inside the JUBE script, which is, I would also call it ad hoc, but at least it's auditable in some way. And others were doing GitLab CI based, so they were creating different jobs in their GitLab CI to build, and then they were using that as artifacts to run it. So again, kind of ad hoc, but still more auditable or cacheable. And this is not good for us. This is not good for us because this means we have a lot of blind spots about important dependencies. This means that the number of projects that can be integrated in our system studies are very restricted. This means that our ability to help users with potential bugs is restricted. Our ability to plan changes to the system, like for example, which frequency to set by default or for energy efficiency, that is restricted. But also there is a lot of duplicated work because a lot of applications are now building their own dependencies, which might not be the most optimal, or it's a waste of their time or stuff like this. So then we tried to figure out what were the reasons they were doing this, and so I have tried to combine this now, the reasons and the potential solutions that they have. So the reasons were long build times for some of their dependencies, which can be probably solved by caching. In general, or already built dependencies in specific. They had very complicated build processes, and so this is a more difficult part where you want to bring them to dependency management. Uh, they had modules which is not available in EasyBuild, so this it depends, because so this is much more restricted. Finish this button. So modules not available in EasyBuild. Custom modules. We have customized build for each configuration. Sometimes, like for Cocos, sometimes you have to do this. Even for Petsy, if you want to do a complex and a double, there are two different options, and you want to do all of this dance. There are custom versions of the modules. This really happens in early access, where we are really testing for bugs and trying to build our own patches, and applications are also helping us, and they are also building their own patches and stuff like this, and we really want the synergy to work. And custom compilation options, and very importantly, we need reproducibility at the later date, which sometimes means 3 years into the future, because EU projects run 3 years. So at the end of 3 years, you also want to be able to run what we're running before, and so we need log files. So all of these problems were there, and that's why people were not completely using EasyBuild. And so I tried to find, my job a little bit was to try to find solutions to this, what can be done, what cannot be done. And what I have here is the current tools. So I tried to look at this, I tried to think of solutions, and I tried to think of what could be done differently and what we need. So these are kind of suggestions slash gripes slash my ignorance maybe of what happens. So EasyBuild, we have suffix to separate different things, but I think we also need maybe variant and toolchain fields along with suffix. rpath, I very intentionally put this here like this, in not run path slash rpath, because I always get confused, and I think this is important, and that's a good thing. But what we need really from EasyBuild is chaining installations. What this means is, if a system has its own GCC and OpenMPI running, then someone should be able to chain based on it and build their own dependencies, which might already exist in the system, but then they build it with their own custom flags and stuff like this. So I don't know how many of you know about the user installation module at JSC. Little bit. So this helps a little bit, because then you can load this user installation module and build your EasyBuild itself, build your EasyBuild modules themselves. But then you have to manually set up the caches. It's not easy to inject custom dependencies deep in the chain and stuff like this. And because it's not that popular, we don't have a lot of institutional knowledge. And then we have Easy. So Easy, I tried also using it for some stuff, and I think the S3 part of Easy, I think they do have support of S3, but it's not that used, I guess. I'm not sure. I think this is very important, because a lot of people are not going to be able to upload to servers, but then JSC is offering a Minayo, and a lot of people are able to upload to S3 buckets or GitLab packages and stuff like this with S3 interfaces. So this is important. The CVMFS, and it has a periodic refresh. Has a periodic refresh and not an on-demand refresh. Sometimes it checks every interval, and this is not useful in CI, because in CI your job might not be able to wait for this. It's a little bit ergonomic to use without root, and also we need this in CI, because people want to be able to run stuff without system without system interference and in their own locations. And per user file paths are also not possible. Multiple caches per user, which we need for independent and parallel CI runs with conflicting requirements. I'm not so sure. And this is more geared toward broadcasting downstream. When in CI, generally when you use the caches, what happens is that people build the cache and then they upload the caches for use for the next time. This is all. and this is not, this is a little bit problematic sometimes. And so yeah, so I now suggest something from very, as a user, what I would like to probably see here sometimes is, I want a single point of usage mostly for users, because thanks a lot. I want a mostly single point of usage for users, because they should be able to use the modules, but then they should also be able to build the modules as required for them. And they should be using a very similar workflow, whether it's on their desktop or their HPC centers. This is how you get users to be familiar, I found, with your systems. If you only have your workflow on your HPC system, then they will develop their code on HPC systems, and then they lose access to a lot of nice things. Well, VS Code helps, but it's not always the solution. And then CI containers as well. So they should be able to test their stuff on CI and their desktop before they actually run on the HPC center. They should be able to chain the installations. So the HPC center should be able to provide the core packages, and then they should be able to, for example, build their own packages, especially if they are starting out a new project and they have 3-4 different libraries and they are not sure whether they are going to be stuck with this or consolidate this into one library in future. They might not want to upstream this into EasyBuild configs yet, but they still want to build it with EasyBuild because they want this single chain of command. And so they should be able to do this, but then they should also be able to use the already existing packages. We need first class support to download and upload caches, because a lot of times what people will do is they will build stuff, then they would test it and they will think, yeah, this works, and now they want to upload it. So it's a very interactive process for them, and so they want to do this. Support for injecting a specific dependency is also very important, because oftentimes what we want to do is we want to test one MPI solution and then this doesn't work, so now I want to test parastation MPI, but I want to keep the whole other stuff the same, and now I should not have to change the whole EasyBuild configs to get this single dependency somewhere in the chain, especially with now ABI compatibility. This should work. Reproducibility at a later date I already talked about. We really, I think, log files, you can do log files today with module lists, strs, and then all of this, but I think it's important to have very first class support for this again. Uniform names for core packages across different systems are important, I feel, because then the scripts become much more simpler for the users. When the scripts become much more simpler, they are more willing to test your applications on different systems. You get users who are more productive, and all of this. Ability to experiment and freeze the current state is very important. So people will experiment with different packages till they find one that works. They will build different packages till they find one, and now they just want to freeze this and upload this for their next use. And now if you tell them that no, you have to go back and now write the EasyBuild for all of this, now they have to do all this process again, and this is essentially the double time, and you know, they most of the times they won't do it, or they would do it badly, or they would stop using the solution. All of this, like if you achieve all of these factors, I feel sometimes if you achieve all of these factors, we get users and admins on an almost equal level, where the building and the using of the packages is very similar, and this will get you a lot of community contributions from the users who are on desktop systems, but also a lot of community testing. And I feel there is a lot of testing budgets that are available in a lot of EU projects when they apply for compute time, but then this is used very ad hoc in some manner, and a lot of this testing can be done through that projects. And so yeah, so in all, I feel that the reproducible builds are very important somehow, and the users need to be included in them as much as the admins. And I am not sure what's the, I brought this example because I thought it's important to at least come up with some idea when asking for or asking how to do stuff. Maybe this is the idea, but then I would be very interested in what are the alternatives or what are the things I should look at when I want to achieve all of these goals.
Hi. Hello. When you developed this, did you check on reframe?
Yes.
And
So, yeah, we started with JUBE because we had the expertise in house to see what we could do. But technically, there is no. I mean, instead of this, this we could use reframe. There is no. There is nothing blocking this.
the whole thing, reframe can use JUBE. Yeah, that's what I'm asking.
Sorry.
Reframe could use JUBE.
Reframe would be another testing, like it would be another way to achieve reproducible benchmarks, right?
Yes.
Yeah, yeah.
But the thing is that is already for years ready.
Yes. Yeah. We made this choice, but like as I said, we are not stuck with it. We can change it. If people want to use reframe, they are free to use reframe. We would develop a.
Okay.
I mean, I think a lot of what you talk about, certainly at the end, is all about this like developer mode in EasyBuild, which doesn't really exist. It's more like this reproducibility. We're really hard on that, and then this capability to just change dependency kind of exists, not really, and it's difficult because you rely on the recipe existing, right? If it doesn't exist, it doesn't work, right? So, but that's not trivial, right? Because if a version changes doesn't mean the entire recipe to build that thing has remained the same, right? You would have to verify that. So it's not.
You have to solve this satisfiability problem, and then you have to see whether it actually, and then give the error to the user. But yeah.
I mean, there is this feature inside EasyBuild like to try update depths. So it does this kind of thing based on what's available, right? But it'll only work what's available. And then typically, if you're on the bleeding edge, you're not interested in what's available already. You're interested in what's coming or there already, what's coming right now.
So, if I understood correctly, the users, so the researchers, are the ones making the benchmarks,
Yes.
and they do that. It's not It's not mandatory for the project or something. Like, I'm surprised actually that they do. That they do put the effort to do benchmarks.
It's a little. It's a little bit of carrot and stick. Sometimes, yeah.
And then what happens with the benchmark data? Who monitors that? So, do you have some team looking at the data and taking action if something changes performance, or is also that on the researchers to report?
No, this is on. So this is a little bit on the. We are still working with it, but we have access to the data as well. So, for example, when we updated the new driver, or when we ran some of the benchmarks ourselves to check whether the performance is good or not, so we could do that, and we were then. But then the users can also do this, and then they report to us that this benchmark was running a month ago. Now it's not running. What's the problem? So both of us can do the things.
Okay, thank you.
Yeah, I'm here for the whole week. Yeah.